Hi students, this is Miss Johnson with your first notes of the year, 01, rational versus irrational. Go ahead and set your page up in Cornell Notes just like this screen. Draw the line down the middle. You can draw one line going across. Just a reminder with Cornell Notes, we're going to put our notes and our work on the right, and we're going to put the questions on the left. In the top left-hand corner of your paper, go ahead and put that our students will be able to know the difference between rational and irrational numbers. All right, we're going to start off with two vocabulary words. First one is rational number. Go to page R in your vocabulary section and put down rational number. And the definition is a number that can be written as a ratio or fraction, decimals that stop or repeat, and perfect squares. And these numbers can be positive or negative. An irrational number is our other vocabulary word. So go to page I in your vocabulary section. And it's a crazy decimal that never stops and never repeats. And the most common example is pi. It goes on, never stops, never repeats. All right, back to our notes. Let's do some examples. So on the left-hand side, here are our problems. You want to copy them down. It says, are these numbers rational or irrational? Well, let's start with number one. We've got negative 23. Negative 23 is a whole number. It is negative. It's not a crazy decimal, so this number is rational. Number two, 5.368. This is a decimal, but it is not a crazy decimal, so it's rational. The decimal stops. That makes it rational. Number three, the fraction 3/8. These ones are almost the easiest ones. It is rational. Any fraction, no matter what the numbers, any fraction is rational. Number four, square root of 45. Well, first we need to figure out what the square root of 45 is. Alright, so I've got my graphing calculator here, and we need to put in the square root of 45. The square root is in yellow right here above the x squared, so I'm going to do second square root. I'm going to type in 45. Notice it has a parentheses for the beginning. We always need to put a parentheses at the end. Alright, hit enter. And we get the decimal, 6.708203932. That is a crazy decimal. It is long, it does not repeat, and actually the graphing calculator is smart that if this was rational, it would turn it into a ratio, it would turn it into a fraction right on your calculator. So the square root of 45 is a crazy decimal, therefore it is irrational. Number five, 4.238916 ... This number is also irrational. That ... at the end is the way to indicate that it doesn't stop. And if it doesn't stop, it's irrational. Number six is the square root of 49. So let me grab my graphing calculator again. Let's put in the square root of 49 and my parentheses. And the answer is 7. 7's a nice number. That means it is rational. Anytime you get a whole number, square root, it is a rational number. All right, here are some examples. Go ahead and draw a line across your piece of paper. At the end of all the notes, we are always going to summarize. So go ahead and you're going to write down these sentences and fill in the blanks. A rational number is, explain what it is. And then an example is, give an example of a rational number. Don't do one of the 6 that I just gave you though. Come up with a new one. And then also, an irrational number is, please explain what an irrational number is. And then an example is, give an example. Again, not one of the 6 that we just did. Alright, this is Miss Johnson with your first video note, 0-1, rational versus irrational.